To close out the sequence on multiples of pi over 6 on the unit circle, I want to go ahead and think about a circle of a radius that is not 1. Right? We want to evaluate trig functions for multiples of pi over 6 or 30 degrees. Right? Recall that 30 degrees brings to mind the right triangle. That's 30, 60, 90, with sides of length 1, hypotenuse 2, and the side opposite of 60 degrees, radical 3. If I used a circle of radius 2, then I could have just used this triangle to figure out the values of my trig functions. Okay. Let's take a look. So let's say we rotated pi over 6 using radius equal to 2. Then I could have used a copy of exactly this triangle in quadrant 1. Right? Then the coordinates of this point on the circle of radius 2, the x-coordinate is just the length of this leg, radical 3. The y-coordinate is the length of this leg, 1. And I could have used that point to evaluate my trig functions. But again, as we saw with multiples of pi over 4, we have to keep in mind that we have to divide our coordinates by the radius. Right? So cosine of pi over 6 is going to be the x-coordinate, radical 3, over the radius, 2. Right? The sine of pi over 6 is going to be the y-coordinate, 1, over the radius 2. So I could have used the circle of radius 2. The other multiples of pi over 6 would give us points 1 radical 3, negative 1 radical 3, using symmetry at this point, and so on. We could have found all of our values for our trig functions on multiples of pi over 6 quite easily, I think, using a circle of radius 2.